And here we are. Okay, cool. So today we're going to be talking about relations and functions. This first slide you're going to find is a lot of definitions. It's a lot of just new vocabulary. So let's go ahead and get that out of the way first. The first three sentences here are just words that we need to fill in. A set of input and output values, usually represented as ordered pairs, so go ahead, is called a... It was a good try, though. We call it a relation. Relation. So we can relate input and output values. And I'm seeing you there, I'm watching you. I don't know, I'm having fun, that's all it is. So, what we're going to see is that the numbers that we input, or the numbers that we start with in a relation, we call those, the group of those, we call that the domain. So the domain is where we start. We start with some numbers, and those starting numbers, what we call an input, they're related to some output numbers. So we start with the number, we do something to it, and then we get a number as a result. And the group of those output numbers we call the range. The domain is the start, the range is the finish. We've done stuff like this before. If you've ever filled out an XY table, the X's are where we start, that would be our domain, and the Y's are where we finish, that's our range. So as we proceed through this, think X's and Y's. A good way to remember the terms domain and range, D comes before R in the alphabet, so domain comes before range, X comes before Y. That's just a silly way to help you kind of remember that. All right, so you've got two examples here. What we're trying to do is we're trying to find the domain in the range. And this is very easy. I don't want you to overthink this. The domain is really just all of the numbers that are X coordinates. So I'm going to kind of underline all of the numbers which represent my X coordinates. And all I'm going to do is put them in numerical order, and I'm going to put brackets around them, or braces. So little curvy parentheses there. My smallest number that I see is -2, then I see -1, then I see 3, and then I see 5. All I did was I took those first coordinates, or the X coordinates, I put them in numerical order going from smallest to largest. And I put them in a list, I put commas in between, and put the braces around. Then I'm going to, instead of underline, I'm going to overline all of my Y coordinates. So -2, 0, 4, -1, just so I know which ones are which. And I'm going to put those in numerical order. So the smallest number is going to be -2, the next smallest is going to be -1, then I have a 0, and then I have a 4. There it is. That's it. So notice that the relation is just a way to connect 3 and -2 together. The 5 and the 0 are related to each other. They go together. -1 and 4 are related. -2 and -1, they're related. So if you feel good with this, you're like, oh, that's easy. Jump ahead to number 2. There's one small thing that's different about number 2 that we need to address, and it's the first part with the domain. The domain is all of my X's, so it might be helpful for you to underline all the X's. And the issue that comes up here is notice that the -3 repeats. There are two values, or two ordered pairs, that have -3 as a domain value. When we write the domain out, there's no sense in writing it twice. If we know that -3 is a member of the domain, we already know it's in the domain. We don't need to write it again. And so we can go ahead and just put -3, and then my next number would be 0, and then I've got a 1, and then I've got a 4. So even though there are 5 ordered pairs, there are only 4 members of the domain because the -3 repeats. And then when we go to the range, again, I'm going to overline all of those numbers, and so that's going to give me, put them in numerical order, -2, -1, and then we've got 1, 2, and then 5. And that is identifying the domain and range just from a bunch of numbers. Okay. Kind of taking this one step further, more definitions, more vocabulary. The next sentence we have there is a relation in which no inputs or x values repeat. We have a special name for that, and I think that's the one that Solomon was going for. That is a function. So a function is a special type of relation. A function is a very special type of relation in which none of the x values repeats. So if we were to go back to number 1, there were 4 ordered pairs, 4 numbers in the domain, none of those x values repeated, so this would be a function. So it is a relation, but it's also defined as a function. Whereas with number 2, we saw that the x value -3 repeated, so this would be an example of something that is not a function. So you're always looking for that repeating of the x's. You want to make sure that they don't repeat. We're also sometimes going to be graphing relations or graphing functions, just like we would graph x and y coordinates together. We've done that before. That's not anything new. But there's this thing that we can use to determine if a relation also can be considered a function, and the name of that is the vertical line test. So the vertical line test can be used to determine whether or not a relation it can also be considered a function. And so we're going to have some more examples. We're going to go 3 through 8 in just a second to determine whether or not something is a function or if it's just a relation. So vertical line test. And the way that works, it says if you cannot draw a line with more than one point from the relation, then it is a function. So if you want something to be a function, then you don't want more than one point on the line. So if you pass through one point, it's good. If you pass through 2 points or 3 points or 4 points, then it fails the vertical line test and it fails to be a function. So for questions 3 and 4, question number 3, I'm going to just kind of highlight my points a little bit better so that you can see them. What I'm going to do is I'm going to start thinking about drawing vertical lines. And so if I draw any vertical line that has more than one of these points on it, then it fails the vertical line test and fails to be a function. And so I can draw a vertical line here. If there's only one point on that, we're good so far. If I were to draw a line down here, there are no points on it, and that's okay. We don't want more than one. So any vertical line that I draw, it doesn't matter where it is, I'm only going to have at most 1 point on that line, and that's okay. So we would say that this passes the vertical line test, and this is a function. So question number 3 is indeed a function. It passes the vertical line test. Another thing that we could have done is we've got coordinates. I could have listed them out, say -5, -1, -2, 3, 0, 4, and could have done it the way that we did the other way. Here's number 4. Let's highlight the points a little bit better so that you can see them. And if you notice, I'm going to draw a line through those points right there, and because there are 2 points on the same vertical line, that would mean that these x coordinates would repeat. Both of those points have an x value of -3. And so because of that, it fails the vertical line test and is not a function. So for question number 4, that is not a function because that first line that goes through those 2 points means that we fail the vertical line test. Question number 5. We're going back to that old style relation where we just have the ordered pairs. And all we're looking for in a function is whether or not the x values repeat. So I'm looking at -2, 6, 5, and -1. -2, 6, 5, -1. None of those numbers repeat, so it is, yes, a function. So we could say that number 5 is a function. One of the questions that comes up pretty frequently is, well, Mr. Platek, take a look. The y's have 2 1s in them. Is that a function? Yes, it is. I don't care what happens with the y's. It's all about the x's. All right, so just take a look at those first numbers and see if those repeat. Question number 6, I'm looking at those first coordinates. I'm ignoring the y's. That has nothing to do with whether or not we have a function. And I take a look and see that the number 4 shows up twice. And so because of that, question number 6, that relation is not a function. Question number 7, question number 8, you'll notice that those are just XY tables. It's the same thing. You have an X, you have a Y, it's in a table. The X's and Y's aren't in an ordered pair form. So again, you're looking for the X's, -3, -1, 0, 2, 2. Oh, yeah, they repeat. The 2's repeat. So that means that we have not a function. So for that, we do not have a function for number 7. And when we go to number 8, we've got -5, -2, 1, 4, 8. None of those numbers repeat, and so we can say that we indeed have a function.
For the interruption, teachers and students, teachers, just a reminder, this period, please remember to pass out the permission and liability release slips to the students, and they are due back on Thursday. These are to be passed out second period, and students, they are due back by Thursday. Thank you.
So do you remember that message playing earlier today? Yeah. All right. Anyway, so remember, this is for third and fourth period. Anyway, kind of finishing up the bottom of page 1 there. There's one other thing that kind of shows up with functions, and it's like a formula. We've seen things like y equals mx plus b, y equals some equation. The idea is we would plug a number in for the x and solve for the y. That's how we establish an xy table. Functions can work a lot like this. You can plug a number in and you get a number out. So there's a formula that usually goes along. This thing right here, that f with an x in parentheses next to it, we say something for that, and we would pronounce that as f of x, f of x. The f is there to stand for the word function, to let you know that the formula that you're looking at, if you were to graph it, would pass the vertical line test. That f can change letters, and a lot of times we change the letter based on what we're talking about. So, for example, we're talking about supply and demand. There would be 2 different functions. There would be an s of x for supply and a d of x for demand. And it's just used to help us keep track of one equation versus another. The way that this works is we can plug a number in for the x. So it says, let's say we wanted to let x be equal to 3. It says anywhere where we see an x, we're going to replace with the number 3 and then simplify it. So I'm going to take this equation, which was f of x equals 2 times x squared minus 5x, and anywhere in that equation where I see an x, I'm going to replace it with a 3. And so I'm going to say f, there's an x, I'm going to take out a 3, so that's now becoming f of 3 is going to be equal to 2 times, there's an x, I'm going to put that in parentheses, 3, and so that's still being squared, minus 5 times another x, and again, wherever we see an x, we're going to replace with a 3, and we can simplify that. We can do this with any number. If I wanted to find out what the output value is when x is equal to -2, we could do that. If we wanted to do it with 0, we can do that as well. Now all we have to do is simplify this. So the f of 3, that doesn't change. That just kind of stays down. There's no math to do there, so we just bring that down step by step. The right side, though, we can simplify that. It's just a formula. 3 squared is equal to 9, so that's going to be 2 times 9, minus 5 times 3 is 15. And so f of 3 is going to be equal to 2 times 9, which is 18, minus that 15, and when we put it all together, f of 3 is equal to 3. And that's what we're looking for. what this notation tells us, what that looks like is, it tells us what the x value was that we started with, and it also tells us what we got as a result. So it tells us that if you take the number 3, plug it into the function labeled f, you get the number 3 as an output. And so it's a coincidence that the input and the output happens to be the same number. It doesn't always work out that way. So that's all we're really doing with that, is just taking a number, plugging into a formula, getting another number as a result. Let's take a look at a couple more examples, and I believe we're at the top of page 2 now. All right. Yeah. That's a multiplication, 2 times 9.
Oh.
Yeah, that's not 2.9, that's 2 times 9. So for question number 9, it's telling us that we have the function f of x equals 3x minus 7, and we want to evaluate. Evaluate means bring a value to. And so for x equals 6. So what we're trying to find is, what is the function, and what do we get when we plug a 6 in for x? So anywhere in that equation where there's an x, I'm going to replace with 6. So I've already done that for the f of x thing, so that becomes f of 6. And that's going to be equal to 3 times, there's a 6, there's an x, so we put a 6 in there, and then minus 7. And so f of 6 is, again, there's no math to do there, so we just bring that down. 3 times 6 is 18, minus 7, and finish it up, f of 6 is going to be equal to the number 11. And again, we like this because it tells us where we started and where we finished, and what we did in between. We plugged it into the f function. So we started with the number 6, we plugged it into a formula, and as a result, we got 11. All right? Number 10, notice that that's not f of x anymore. I've changed the letter of the function, so I would tell you that it's a g function, and the g could stand for anything. And then the variable that we're plugging into is not an x anymore, it's actually a t. So it's telling us, use this function and figure out what we get when we plug in -4 for t. So I'm looking for g of -4. So wherever there's a t, swap that out and plug in a -4. So I have g of -4 equals 1/2 times, there's a t, so we're going to call that -4, still being squared, and then we have a plus 10 at the end there that we can't forget about. And now we just bring down the g of -4, do the math. -4 squared, when you type this in your calculator, be careful. Either put parentheses around the -4, or just know that -4 times -4 is a positive 16. So that's half of 16, or half times 16, and then plus 10. G of -4, again, we're just bringing that down step by step, is equal to half of 16. Half of 16 is 8, and so that would be 8 plus 10, and 8 plus 10 is equal to 18. So put it all together, G of -4 is equal to -18. Or sorry, positive 18. G of -4 is equal to 18. Question number 11, again, to give you a new formula, or new function. It's the h function now. We've changed the letter to a, and it's asking what is h of 2. So this is just telling you, what do we get when we plug 2 in for all of those a's. So h of 2 is going to be equal to, and there's 2 spots where there's an a, so that's going to be 2 squared minus 3 times 2, and then plus 7. And so now we've got h of 2 is equal to 2 squared, which is 4. -3 times 2 is a -6, so that's 4 minus 6, and then plus 7. And 4 minus 6 is -2. -2 plus 7 is a positive 5. So h of 2 is equal to 5. For question number 12, this one looks a little bit different. Take a look at what's going on here. So if f of x is equal to 7x minus 9, so they're telling you the formula, we are given f of a is equal to 61. What is that value a? So what they're telling us now is there's some number, and when I plug it into that function, I get 61 as a result. And so what we can say is, all right, well, I don't know what number I plug in, but if I plug it into this formula, f of a is going to be equal to, anywhere where there's an x, call it a. So I've got 7a minus 9. Well, that 7a minus 9 has to be equal to 61. So I can set that equal to 61, and I can kind of ignore this part now and just look at the 7a minus 9 equals 61. And that's an equation that I can solve for a and work backwards. So if I were to add 9 to both sides, that gives me 7a equals 70. Divide both sides by 7, and that's going to tell me that a is equal to 10. So that one's a little bit different. Like you had the answer and you had to work backwards to find the question. So all this question is saying is, what number do you have to plug into that formula to get 61 as the output? So you have to kind of work backwards, and when we did that, we found out that if you plug in 10, you'll get the number 61 as your output. For question number 13, it says here, the domain of the function m of x equals negative 2x plus 3. That's going to get me negative 3, negative 1, 0, and 2. What they're looking for is the range of m of x. What is the range? So remember, the domain, that's kind of like our x's. That's the numbers that we plug in. The range is like my y's, and that's what I get out. So all I'm going to do, and it's going to seem kind of tedious, like we have to do it a bunch of times, but I'm going to plug in negative 3 into that function. Then I'm going to plug in negative 1 into that function, then 0, then 2, and that's going to spit out all of the range values for me. So I'm really trying to find m of negative 3, m of negative 1, m of 0, and m of 2. So what are the output values for each of those domain values? And we get them just by plugging those numbers into that equation, so the negative 2x plus 3. So to find m of negative 3, that's negative 2 times negative 3, and then plus 3. And I'm going to say, to kind of save us a bunch of writing, if you just want to plug that in your calculator, if you want to figure it out that way, you can just type it in just like that. Negative 2 times negative 3 is positive 6. Positive 6 plus 3 is going to give me the number 9. So 9 is in my range. That's one of the range values. Now let's plug in negative 1. So that's negative 2 times negative 1, and then plus 3. So negative 2 times negative 1, that's a positive 2. 2 plus 3 is going to give me 5. So 5 is also in my range. M of 0. So plug in a 0, negative 2 times 0, then plus 3. Negative 2 times 0 is 0, plus 3 gives me 3. And then we have m of 2, so I plug in 2, negative 2 times 2, and then plus 3. Negative 2 times 2 is negative 4. Negative 4 plus 3 is going to give me negative 1. So if I put that all together to find my range, let's put those in numerical order. Let's go negative 1, 3, 5, and then 9. That's the range. That's what we were looking for there. All right. All right. I'm going to stop there. We will come back to those graphs, but we'll try to do that tomorrow. We'll kind of talk about that. What I'm going to ask you to do now is to flip to page 3 of your booklet. And on page 3 of the booklet, you can see that there's lots of different types of questions. So let me just kind of share with you the problems that you're going to be working on, and then we'll go through and we'll talk about them. So it is going to be questions, so page 3, and it's going to be questions 1 through 8. And then it is going to be 10 through 22 even. All right, so it's going to be questions 1 through 8 and then 10 through 22 even. For questions 1 and 2, all they're asking for is the domain and range of each relation. So you're just picking out the x's, put them in numerical order, picking out the y's, put them in numerical order. For questions 3 through 8, you're trying to determine whether or not each relation is a function. For questions 3 and 4, remember, make sure none of the x's repeat. We'll come back to questions 5 and 6 in a second. For question number 7 and 8, you're trying to see if it passes the vertical line test. So see if you, when you draw a vertical line, will you cross over that graph more than once? If you cross over it more than once, then it fails the vertical line test and it fails to be a function. For question numbers 5 and 6, those are what we call mapping diagrams. I'm not usually a big fan of them, but I at least want you to kind of look at that. What that does is the numbers in the left bubble or that left oval are like your x values, and then they point to a y value that they go with. So for example, in question number 5, if you look at the number 1 in the left bubble, it has an arrow going to -1, which means that 1, -1 would be an ordered pair in that relation. The next would be 3, 4, because the 3 goes to 4. The 5 also goes to 4, so that would be the points 3, 4, and 5, 4. The x's don't repeat, but the y's do. We said the y's are okay to repeat. And then for question number 6, notice how the number 0 goes to -1 and goes to 0. So that would be 2 separate ordered pairs for that. For questions 10, 12, and 14, you have 3 different functions. They're asking you to evaluate each function rule for x equals 3, so you're plugging a 3 in for each of those functions. For questions 16 and 18, you've got 2 functions there. You're plugging in a -1/2 to each of those, so kind of the same thing. And then for questions 20 and 22, I've given you the domain and a function. You want to plug those numbers in to find the range. Okay? Question number 22 has something called absolute value. And if you're not familiar, absolute value is a very easy concept. Absolute value of x is always positive as a result. So if I said absolute value of 7, the answer is 7. So if you take the absolute value of 7, it's equal to 7. If you take the absolute value of -3, it's just 3. So it keeps the number, but just makes the sign positive. Positive stays positive, negative becomes positive also.